All right, in this video we're going to take a look at the remainder theorem, not the factor theorem, we'll put that on hold, but the remainder theorem. And by definition, the remainder theorem is defined by when you divide a polynomial function by x minus c, the remainder equals f of c. Now at this point, without an example, this really doesn't make a whole lot of sense, but what I do want you to notice is that we're dividing a polynomial by a binomial in the form of x minus some constant. This is also the same scenario that we need when we divide by, divide synthetically. So keep that thought in mind. Let's take a look at an example. So in your notes, example 1, we're going to use the same function throughout because you're going to see some comparisons with this. So we're going to evaluate f of 2 of this function, if you remember. To do that, we're going to remove all the x's, create empty parking spaces, so to speak, and we're going to fill those parking spaces up with the value 2. And then we're just going to simply evaluate this. And we're going to get the final answer is going to be x equals -5. Then what we're going to do is we're going to divide this same polynomial synthetically by x minus 2. And what we're going to note here first is that the number that goes in the penalty box happens to be the same exact number that we use to evaluate, because when we solve for x here, we're going to get x equals 2. And so we're going to strip the function of all the variables and just replace them with the coefficients only. We're going to drop this down to line 3 and multiply and add, multiply and add, multiply and add, and our final answer, or the remainder of this, is -5. Now when you're doing this, you don't have to put the variables back in. You're just looking at the remainder. That's why it's called the remainder theorem, so let that set in. What I do want you to know is that these two match, and that is not by coincidence. That's going to happen every single time. The remainder will match what we use to evaluate. Okay? And again, this will happen every single time, and that's why it is called the remainder theorem. So whenever you see the instructions use the remainder theorem, your answer is the remainder. All right. So let's take a look at what that looks like graphically. If I were to take that function and put it on a piece of graph paper, this is what it would look like. Now remember, we input the value 2 and the output was -5. So 2 -5 is a part of the story of this graph. Again, that's not by coincidence. Let's take a look at a few more problems, examples using the same polynomial function, and I just want to show you that it happens every single time. So again, what we're going to do is evaluate at f of -1, and we're going to remove all the x's, and we're going to implant a -1, and we're going to evaluate each one, and our final evaluation is -11. So when we put in -1, we get -11. We're going to do the same using synthetic division. Again, the -1 that we put over here in the penalty box is obtained by solving for x here. We're going to strip this equation right here of all of the variables and put just the coefficients down. We're going to drop the 1 to line 3, multiply and add, multiply and add, multiply and add, and voila, what do you see? You see that the remainder is the same exact answer or evaluation at of -11. Graphically, again, what we're going to do is we're going to look at the ordered pair -1, -11, and we're going to see that it's part of the story of this graph. All right, one more example just to show you that the remainder theorem is consistent throughout. So this time we're going to evaluate f of 3. And again, we're going to take out the x, put in 3, do an evaluation, we get the answer 1. Then we're going to synthetically divide, multiply and add, multiply and add, and guess what? Those numbers once again matched up. The ordered pair 3, 1 will appear on this graph. This is the x-axis right here. If you go to 3 and 1, it's part of the story of the graph. So that, folks, that's how the remainder theorem works. Now, when you do your homework, the wording in the book uses a phrase called synthetic substitution. And I'm not really a fan of that wording, but I can't do anything to change it. So just keep in mind when you see synthetic substitution that they're just referring to synthetic division. Okay? So hopefully this has helped, and make sure you get your notes filled out. We'll see you in class. Get that homework done. You'll see a couple problems like this. All right. Have a great evening.